Okay, so from here, you may want to label your side lengths as opposite, adjacent, hypotenuse, like you've been doing. So opposite, adjacent, hypotenuse, like this. And then you can go ahead and fill in your ratios. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So there's your three trig ratios for the traditional trig functions. Now we do the reciprocals. So reciprocal of cosecant is sine. So 25 over 7. Secant is the reciprocal of cos. So 25 over 24. And cotangent is the reciprocal of tangent. Voila. Oh, none of those reduce, by the way. All right, challenge question. So this one is a challenge question because it gives you a reciprocal function. So I want you to first go back to your notes or just think, which reciprocal function does secant represent? So secant represents the reciprocal of cosine, okay? So what I'm going to do is I'm going to actually rewrite this in terms of cosine, meaning if secant is 4, then cosine would be the reciprocal of that. And what is the reciprocal of 4? Well, you just take 4 and flip it, and it would become 1/4. So that means that when I draw my right triangle, 1 is going to represent the adjacent side, and 4 will represent the hypotenuse. And I know that because cosine is adjacent over hypotenuse by definition. So we're going to draw a right triangle, or at least try to. You're going to label what you know. Here's my theta. I can put theta wherever, but I usually try to be consistent and just keep it in the same place. But theta is here, and then adjacent would be 1, so that'd be that side, and hypotenuse would be 4. And then I need to go over to the side and try to figure out what this guy would be. Okay, so we're doing Pythagorean theorem again. A squared plus b squared equals c squared. Remember, c is always the hypotenuse. So 1 squared is 1, 4 squared is 16. Subtract 1, you get 15. Square root both sides, and you're going to get just radical 15 because I'd rather not deal with decimals. Okay, so my missing side length is radical 15. Okay, I'm going to label opposite, adjacent, hypotenuse, and just kind of do what we've been doing. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, which we already knew because we figured that out with what was given. Tangent is opposite over adjacent, which I guess I should probably just write it as radical 15. Looks neater. Okay, cosecant, flip the sine one. It's the reciprocal of sine. And then this time you're going to have to rationalize to make it nicer looking. So we're going to multiply by radical 15. And I ran out of room, so I'm going to have to go up here. So it'd be 4 radical 15 over 15, which doesn't reduce. So that's your answer. Secant is the reciprocal of cos. That is going to be 4, which again, that was given in the problem. And then cotangent is the reciprocal of tangent. So that would be 1 over radical 15, but rationalize like you did for the cosecant function. So it would end up being radical 15 over 15. All right, so that's kind of part 1. Part 1 is really just kind of working with these new trig ratios that you have here on this slide. Okay. Part 2 is we're going to do some things you did in geometry class, but and this is like using your trig functions to find missing values where Pythagorean theorem isn't going to cut it. Okay, so like this example, I've got a missing side length, actually 2 missing side lengths, and I do know the hypotenuse, but I don't know the other side, therefore I can't do Pythagorean theorem. So then what do? I go to my trig functions, and we're going to stick with the 3 main ones, sine, cosine, and tangent. And I'm going to figure out which one of these I could use to help me solve this problem. Here's what we know. We know that this angle down here is 64, and we know that this side would be opposite of that angle. And we know that 2.7 is the hypotenuse because it's the longest side of my triangle. So if I know an angle measurement and I know this is opposite and hypotenuse, I'm going to be able to use sine to help me solve this problem. So what I'm going to do is I'm going to write the formula for sine, which is also on that first slide with all the definitions. So the sine of theta is opposite of hypotenuse. So the opposite and the hypotenuse is clearly opposite is x. Hypotenuse is 2.7. This time though, we know theta. Theta is always an angle measurement. We have that. We have 64 degrees as the angle measurement. Okay, so this guy down here is theta. So what you've done is you've created an equation for which you can solve for x. Okay, so how would you solve for x? Well, you would multiply by 2.7. So you'd be doing 2.7 times sine of 64 degrees. Now from here, you have to use a calculator. So I'm going to switch over to my calculator. By the way, this is an option on Desmos. You just type in desmos.com/scientific and you have a little calculator here. I need to type in 2.7 times sine 64. So 2.7 times, here's sine, and I need 64. Now I do need to make sure it's in degrees. So see this little toggle switch? It's going to switch you from degrees to radians. We want to be in degrees. So my answer is 2.427. 2.427. But it does say to the nearest tenth. So 2.4 would be my answer. Do we know what that is? That's in feet. There we go. Okay, let's try another one. So same thing, we're going to figure out which trig function to use. What we need to start with is labeling. So here's theta. This is definitely opposite of the angle that I know. And then x over here would be adjacent, right? It's not the hypotenuse, but it is right next to the angle. So I need which trig function uses opposite and adjacent. So take a look back at your notes. Opposite and adjacent is your tangent function. So I'm going to write the formula first. Tangent of theta is opposite over adjacent. That's the formula. Plug in. Remember, theta is the angle. Opposite would be 9.6. Adjacent is x. All right. Now, this one is harder to solve because the letter you're solving for is in the bottom of a fraction. So it takes two steps. First step is I'm going to multiply the x over to the other side. Okay, the next thing I'm going to do is I'm going to recognize that this x is multiplying by the tangent of 32 degrees, which this is just some number that we don't know yet. So what we're going to do is we're going to divide by tangent of 32 degrees. It's going to look like this. Okay, so that's how you're going to do your solving process. The very last thing that I will do is type into the calculator. That's the very last thing. We don't want to type in too soon because then our answers will be off due to rounding issues. So 9.6 divided by, what was it? Tangent of 32. And again, just make sure that you are still in degrees. So it's looking like 15.4 if we round. 15.4, and I didn't see a unit of measure, feet again. Okay, you got that one. Okay, one more like this. So let's label 35 as my theta because that's always the angle. X is the hypotenuse because it's the longest side. This is adjacent because it's right next to the angle. So we need adjacent and hypotenuse, or a trig function that uses adjacent and hypotenuse. The winner this time is cosine. Cosine is adjacent over hypotenuse. Plug in. So you would have your angle is theta. Adjacent is 2.9. X is hypotenuse. We're going to solve this one. It's a lot like the steps from the last example. That means multiply by x first. So you have x times cosine of 35. Divide by cosine of 35. And type in. So 2.9 divided by cos 35. Looks like 3.5. Okay, there's only one more thing we have to go over, and I'm going to do this rather quickly because I think you're getting the point, hopefully, by now. We have a very, very similar situation, except this time we don't know the angle, okay? So you're still going to go through and label. This would be your adjacent. This would be your hypotenuse, just like you did before. And then you're going to set it up just like you did before. So this one, I would need cosine because it's the function that uses adjacent and hypotenuse. And I'm going to plug in just like I did before. Adjacent is 71 and a hypotenuse is 94. Here's where it gets different. The equation is different because the x is inside of the cosine function. Trig functions are not things that work on their own. Like cosine by itself means nothing. Cosine can only work if it has an angle attached to it. Meaning, you can't separate these two things by division or something like that. The only way to get rid of a cosine and just leave you with the inside value is to use an inverse function. And the inverse of cosine is called just inverse cosine. And it looks like this with this little -1. So we are going to have to apply an inverse cosine function to each side of the equation. So I just put inverse cos on each side. And what happens is an inverse cosine and a regular cosine undo one another, and you would just be left with x, which is the degree measurement that we're solving for. So now I need to go to my calculator and I need to type all this stuff in that's over here, which there is a button for inverse cos. So watch me, I'll show you on Desmos. On your calculator, it's going to be a little bit different. On Desmos, it's under function. And here's inverse cos, and I want, what, 71 over 94. So I have to go back to main. 71, whoopsie, wrong spot. 71 over 94, and then make sure I'm still in degrees. So my degree measurement is 40.9. So my degree measurement for x is 40.9 degrees. So that's the angle measurement. That's 40.9 degrees. Okay, I'm going to do one more really quickly just to kind of show you how that works. So this one we've got an adjacent and a hypotenuse. That's cosine again. Actually, maybe let me skip and find. Oh, they're all the same. Okay, whatever. So cosine of my angle is 61 over 89. And I need to apply an inverse cosine to each side in order to find the angle measurement. Okay, remember inverse cos and regular cos cancel each other out and leave you with just x. And so then I need to figure out what cosine, inverse cos of 61 over 89 equals. Let me go to my calculator. Whoops. So inverse cos 61 over 89 is 46.7. And that represents your missing angle. 46.7, right? 46.7. 46.7. Okay, that's it. The examples I had here at the end of the lesson are exactly the same as questions that you have to do for Delta Math. So make sure that you take your time to go through these examples. It should help you tremendously. Have a good day, guys.